when the positive integer k is divided by the positive integer n, the remainder is 11. If k over n is equal to 81.2, what is the value of n? So I find this to be a fairly tricky problem because I am used to thinking of remainders sort of in this format here, where they say something over something is equal to some quotient with some remainder that is an integer, but I am not used to thinking of remainders in sort of decimal form like they have here. And really what they are doing in this question is they're asking you to link these two things together. So you either have to, I guess if you, how hard you find this question sort of depends on how you are used to thinking of remainders. And I am not used to thinking of them with decimals, so I sort of have to either think of, how this fits in with my remainder expression, or find another way to do that. And so one thing you could do if you're unsure how to link these two things is just come up with some examples. See if you can find the pattern and then just apply it to our scenario here. So when I say come up with examples, I mean just come up with some examples for k and n. If I was to just say, 16 over 5, 10 over 4, 29 over 5. And so in each case here, k is my numerator, n is my denominator. And so then in remainder form, what would these guys look like? So 16 over 5 would be 3 remainder 1. 10 over 4 would be 2 remainder 2. 29 over 5 would be 5 remainder 4. So what would each of these guys then look like as a decimal? So 16 over 5 is 3 1/5, or 3.2. 10 over 4, that's 2.5, so that's 2 1/2. And then 29 over 5 is 5 4/5, which is equal to 5.8. And so now if I start thinking, so how do I get my remainder from sort of this guy here? And what it seems like, and so the one thing that sort of stands out to me is that the remainder is always equal to this number, this here, so this fraction or this decimal times my n. So 1 is equal to 1/5 times 5. 2 is equal to 1/2 times 4. And 4 is equal to 4/5 times 5. So now if I apply that here, so I'm really saying in each of these cases, so my remainder, which is 11, is equal to this here, so 0.2 times my n. 11 is equal to 1/5 times n. N is equal to 55. C is the answer. And so another way you can sort of think about it is if you just sort of take a second to think, okay, so like what is this saying in terms of remainders? So it's saying k over n is sort of equal to 81. So, k is equal to 81 n's, n plus n plus n plus n plus n plus n, dot, 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 plus n. This is my 81st n. But then I can't add another whole n. I only can add 1/5 of an n. And they're saying that 1/5 of an n is equal to 11. And so if you sort of see that, that's really all it's saying. And this problem was a lot simpler. N is equal to 55. But if you don't see it, you sort of have to, that's really what makes this difficult, is you sort of have to derive this on the spot. And doing that in a high pressure situation in 2 to 3 minutes can be difficult. So this is how you sort of, usually when there's something I don't know how to do, if I don't skip it to save time, I sort of test numbers and look for patterns. That is sort of how you discover things that you don't already know. See.